Hello everyone. Today we're going to be talking about absolute value inequalities. Just like absolute value equations, you're going to be basically solving two things at once. In fact, that's why we went over the compound inequalities last week. Just a reminder, next week you will be having your Unit 2 test. This is a big portion of your grade, so make sure that you are prepared for it. Later in the week, I will be giving you a study guide to go over. So if you have any questions, please let me know. And remember, do not leave a private comment because I do not see them. Go ahead and get out your notes. Take notes along with me, and once this video is finished, take a picture of your notes and upload them to Google Classroom as normal. Let's go ahead and get started. So whenever we're solving absolute value inequalities, we have two different cases. Case 1 would be if we have a greater than or equal to symbol. Case 2 would be, if we have a greater than or equal to symbol. Or if we have less than and less than or equal to symbol. So those are two cases. The first case is if we have a greater than or equal to symbol. So if we have the absolute value of x greater than or equal to 5, the way we solve this is we break it apart. We say, okay, x is either greater than or equal to 5, or x is less than or equal to negative 5. Okay? So the positive version stays the same, like the symbol stays the same. And then if we make it the negative version, like we would in a normal problem, like a normal absolute value equation, we just flip the symbol. So if we graph these two things, we have x is greater than or equal to 5. We go to 5. We have a closed circle. And the numbers that are greater than 5 are to the right. Okay? So that's the first one done. Now we have x is less than or equal to negative 5. So we go to negative 5. We have a closed circle. And the numbers that are less than negative 5 are to the left. So our interval notation for this one would be parentheses, negative infinity, comma 5, and this would have a bracket, negative 5, since it's a closed circle, unioned with bracket 5, comma infinity, parentheses. So that would be our interval notation for that one, and that's case 1. For case 2, we have the absolute value of x is less than or equal to 8. So if we break this apart, we have that, x is less than or equal to 8, or x is greater than or equal to negative 8. And if we plot this one, we have x is less than or equal to 8. We go to 8. We have a closed circle. We're looking for the numbers that are less than. So it's this way. Then we have, that's the first one. Now we're moving on to the second one. So we have x is greater than negative 8. We go to negative 8. We have a closed circle. And we're looking for the numbers that are greater. So that means that we would go this way. And if you look, this means that we have a combined the inequalities go together. So our interval notation for this one will be bracket, negative 8, comma 8, bracket. Okay? Now, what exactly does this mean? So it means that absolute value inequalities are compound inequalities. As I mentioned earlier. And we can say that if it's less than or equal to, it means that we are going to have an AND case. And if it's greater than, we have the OR case. All right, just like before. So if you remember, in order to solve an absolute value equation or inequality, the first step is to isolate the absolute value expression. The second one is to create two cases. Use the KISS method, I guess. Keep it, switch, switch, to set up the two cases. The third one is solve both inequalities. And the fourth is to graph the solution, write your answer in interval notation. So let's take a look at number 1. Number 1 is the absolute value of x is less than 7. So this is the less than statement. So what we do is we keep it. So we have x is less than 7. Then we switch it. So x is greater than, and we switch it again, negative 7. Okay? So if we graph this thing, well, let's take one more step. So since it's like this, we can rewrite this to be a compound inequality like we did before. So we have negative 7 is less than x is less than 7. So this is actually our answer. So if we graph this, we go to negative 7, we have an open circle, we go to positive 7, we have an open circle, and we connect the two. Since we have open circles, they have parentheses, so negative 7, comma 7, parentheses, and we're done with number 1. Let's look at number 2. We have the absolute value of x is greater than or equal to 4. So we keep it the same, so x is greater than or equal to 4. Then we change it, so x is less than or equal to negative 4. Then we graph these two things. So we have x is greater than equal to 4. We go to 4. Since we have greater than or equal to, it's going to be a closed circle. And the numbers that are greater than or equal to 4 are to the right. For this one, we have x is less than or equal to negative 4. So we go negative 4. We have a closed circle. Since it's less than or equal to, we're looking for the numbers that are less than negative 4, and those exist to the left. Now we have to write our interval notation. So we start from negative infinity. We go to negative 4. It's a closed circle, so we have brackets. We union that, and we jump over to 4. It's a closed circle. So we have bracket 4, comma, infinity, parentheses. And that's our answer for number 2. Let's take a look at number 3. We have the absolute value of x minus 1 is greater than 6. So again, well, since this is already isolated, we just break it apart into two different things. So we have x minus 1 is greater than 6. Then we have x minus 1 is less than negative 6. So remember the KISS method, I guess. So we keep it, we switch it, and we switch it. So this means the symbol, and this means to add negative. Okay? Just keep that in mind. Now, we have to solve this equation. So in order to do this, we have to add 1 to both sides. We have x is greater than 7. Add 1 to both sides. We have x is less than negative 5. Okay, let's graph these two things. So the first one, x is greater than 7. We go over to 7. We have an open circle. The numbers that are greater than 7 are to the right. First one's done. Now we have x is less than negative 5. We go negative 5. We have an open circle. Numbers that are less than negative 5 are to the left. Now we have to do our interval notation. So we start at negative infinity. We go to negative 5. It's an open circle, so we have parentheses. Union with, open circle, parentheses, 7, comma, infinity, parentheses. That's number 3. Let's take a look at number 4. We have x plus, the absolute value of x plus 2 is less than or equal to 7. All right, keep it the same. So x plus 2 is less than or equal to 7. Switch it. So x plus 2 greater than or equal to, switch it again, negative 7. Let's solve this. So we're going to subtract 2 from both sides. x is less than or equal to 5, or 7 minus 2 is 5. Subtract 2 from both sides. X is greater than or equal to negative 9. Then we can go ahead and graph this. So we have x is less than or equal to 5. We go to 5. We have a closed circle. And the numbers that are less than or equal to are in this direction. We have, that's the first one. So we have x is greater than or equal to negative 9. So we go negative 9. We have a closed circle. And since we're looking for numbers that are greater than or equal to, we go to the right. And if you look, we have an inequality that's together. So we start at negative 9 with a closed bracket. And we go until positive 5. And that's a closed circle, so it's a bracket. That's our interval notation, and that's number 4. Let's move on to the next page. With number 5, we have the absolute value of 2x plus 5 is greater than or equal to 3. First step, isolate, which is already done. So now we have to use the KISS method, so keep it the same. So 2x plus 5 is greater than or equal to 3. And then we're going to switch the symbol and switch the sign. So we have 2x plus 5 less than or equal to negative 3. Okay, start solving. So we're going to subtract 5 from both sides. That leaves us with 2x is greater than or equal to 3 minus 5 is negative 2. Divide by 2. X is greater than or equal to negative 1. For this one, we subtract 5 from both sides. We have 2x is less than or equal to negative 3 minus 5 is going to be negative 8. We divide by 2. Leaves us with x is less than or equal to negative 4. All right, let's go ahead and graph these. So the first one, x is greater than or equal to negative 1. We venture to negative 1. We have a closed circle. The numbers that we're looking for are greater than, so we go to the right. Then we have x is less than or equal to negative 4. We go to negative 4. We have a closed circle. We're looking for the numbers that are less than, so that means we go to the left. So with this, we write our interval notation. So we have negative infinity to negative 4. It's a closed circle, so we have a bracket, united with negative 1, closed circle, infinity. That's number 5. Number 6, first step, we have to isolate the absolute value. So we're going to add 1 to both sides before we do anything else. So we have the absolute value of x plus 3 is less than 6. Now we can separate it and using the KISS method. So we have x plus 3 is less than 6. X plus 3. We change the symbol, change the sign. There we go. Let's solve this. We subtract 3 from both sides. So we have x is less than 3. Subtract 3 from both sides. We have x is greater than negative 9. Okay, let's go ahead and solve this, or graph it. So we have x is less than 3. We go over here to 3. We have an open circle. We're looking for the numbers that are less than 3. They're to the left. We have, that's the first one. So we have x is greater than negative 9. We go negative 9. We have an open circle. And we're looking for numbers that are greater than negative 9. So that means we go to the right. And if you look, these are a closed system. So we start at negative 9 with an open circle. So that's parentheses, negative 9, comma. We go to positive 3 with an open circle. So that's parentheses. That's our interval notation. And we're finished. Number 7. We have 3 times the absolute value of 2x plus 8 is greater than or equal to 30. First step is to isolate the absolute value. So we're going to divide both sides by 3. We now have 2x plus 8 is greater than or equal to 10. Sorry, that's absolute value. Now, what we have to do is break apart the absolute value. So we keep it the same, 2x plus 8, greater than or equal to 10. Then we have 2x plus 8 is, we change the symbol. We change the sign. Now we solve. So solving the first one, we subtract 8 from both sides. That leaves us with 2x is greater than or equal to 2. Divide by 2. That leaves us with x is greater than 1. Then this guy I'm actually going to move. So I have a little bit more room. I have no clue what happened. Let's just erase this and rewrite it. So we have 2x. So we have 2x plus 8. We flipped the sign and changed the, flipped the symbol and changed the sign. We subtract 8 from both sides. That leaves us with 2x is less than or equal to negative 10 minus 8 is going to be negative 18. Divide by 2. We're left with x is less than or equal to negative 18 divided by 2 is going to be negative 9. Now, let's graph these two things. We have x is greater than 1. We go to 1. We have an open circle. Sorry, that's greater than or equal to 1. So we have a closed circle. And greater than can be found on the right. Okay, numbers greater than 1 on the right. For this one, x is less than or equal to negative 9. We go to negative 9. We have a closed circle. We're looking for numbers that are less than or equal to. They are to the left. So our interval notation for this one would be parentheses, negative infinity, comma, negative 9. This is closed circle, so we have a bracket, union, closed circle means bracket, 1, comma, infinity, parentheses. And there we go. Okay, let's move on to number 8. We have the absolute value of 4x minus 8, all divided by negative 2, is less than or equal to negative 6. First step, we have to isolate the absolute value, so we have to get rid of this negative 2. In order to do that, we have to multiply both sides by negative 2. Okay, so we have the absolute value of 4x minus 8. Since we multiplied or divided by a negative, we have to flip this sign. So this changes to greater than or equal to. Negative 6 times negative 2 is going to be positive 12. Now we can split it apart using the KISS method. So we have 4x minus 8. We're keeping it the same. This is where we're changing it. So we have 4x minus 8. We flip the sign. We negate the number. Now we just solve the first one. So we're going to add 8 to both sides. We have 4x is greater than or equal to 20. Divide both sides by 4. We have x is greater than or equal to 5. That's part of our answer. Then we have for this one, we're going to add 8 to both sides. We have 4x is less than or equal to negative 12 plus 4 is going to be negative, plus 8 is going to be negative 4. If we divide by 4 on both sides, we have x is less than or equal to negative 1. Okay, this is the second part of our answer. So let's graph these. Let's graph the first one. X is greater than or equal to 5, so we venture to 5. We have a closed circle. We're looking for numbers that are greater than or equal to. They're to the right. First one's done. Let's do this one. X is less than or equal to negative 1. We go to negative 1. We have a closed circle. We're looking for numbers that are less than, so we go to the left. For our interval notation, we start at negative infinity. We go to negative 1. We have a closed circle, so that means brackets, union, with, we jump over to 5. It's closed, so we have a bracket, 5, comma, infinity, parentheses. That's it for number 8. Let's look at number 10, or number 9. We have 10 times the absolute value of x minus 4 minus 3 is greater than 47. First step, we have to isolate the absolute value. So we have to get rid of this 3 and then the 10. So we have to add 3 to both sides. We have 10 times the absolute value of x minus 4 is greater than 50. We have to divide by 10. So we have the absolute value of x minus 4 is greater than 5. Now we have to break it apart using the KISS method. So x minus 4 is greater than 5. And we have x minus 4 is less than negative 5. Add 4 to both sides. We have x is greater than 9. Add 4 to both sides. We have x is less than negative 1. Okay. First step, we have to graph this. So we go to 9. We have an open circle. Okay. We're looking for the numbers that are greater. They're to the right. This one, we have x is less than negative 1. We go to negative 1. We have an open circle. Numbers that are less than negative 1 are on the left. Let's go ahead and write the interval notation. We start at negative infinity. We go to 1. It's an open circle. We union that because we jump over to 9 with an open circle, and we go to infinity. That's it for number 9. Let's try number 10. We have 1/2 the absolute value of 4x minus 4 plus 11 is less than or equal to 15. First step, we have to get rid of the 11, so we're going to subtract 11 from both sides. We have 1/2 times the absolute value of 4x minus 4 is less than or equal to 15 minus 11 is 4. Now, to get rid of this fraction, we're going to multiply by the reciprocal. So we're going to multiply by 2 over 1. Okay, on both sides. So 2 on top, 2 on bottom, 1 on bottom, 1 on top. We're left with the absolute value of 4x minus 4 is less than or equal to 4 times 2 over 1. That's 8. Now we can break it apart using the KISS method. So we have 4x minus 4 is less than or equal to 8. Then we have 4x minus 4. We change the symbol. We add a negative sign. Okay. To solve this, we have to add 4 to both sides. We have 4x is less than or equal to 12. Divide by 4 on both sides. So we have x is less than or equal to 3 for the first one. For the second one, we're going to add 4 to both sides. We have 4x is less than or equal to negative 8 plus 4 is going to be negative 4. Divide that by 4. We have x is greater than or equal to negative 1. Okay, let's graph this. X is less than or equal to negative 3, positive 3. We go to 3. We have a closed circle. We're looking for numbers that are less than, so we draw our line. Now we have x is greater than or equal to negative 1. We go to negative 1. We have a closed circle, and we're looking for numbers that are greater than. So there we go. We go to the right. Our interval notation for this one, we have a closed circle, negative 1, comma, 3, closed circle. That's it for the interval notation. And that's it for the notes. If you have any questions, please let me know. Other than that, please submit a picture of your completed notes to Google Classroom. I hope you have a wonderful day.